Hello, everybody. Hello, my student. Welcome back to Mr. Lee Physics class. Today, we're still in the geometrical optics topics, where today we'll learn the subtopic of curved mirror. The aim of the study is to study the information of image by spherical mirrors. Lesson objective. In this lesson, students use the relationship F equal to R divided by 2 for curved mirror. Draw ray diagrams to show the formation of image by concave mirror and the convex mirror. Derive and use the formula 1 over F equal to 1 over U plus 1 over V. Assume prior knowledge. Students should already be familiar with the law of reflection of light, geometry involving tangent of an angle. Ladies and gentlemen, let's go to the first slide. So we notice that there is a mirror at the shopping center, or the simple curved mirror used as security. So we notice that okay, what's that? The one us security notice you are being watched. Introduction. Next, there will be the other type of mirror. Ladies and gentlemen, please look at the mirror. This is the mirror for the makeup mirror. So that means that what is the type of the mirror used? Is it plane mirror? When the girls go nearer, the image become bigger. So that means that there is a change of the size of the image. Sure, this will be a curved mirror. Introduction. In this lesson, this will be the objective for this lesson today. Radius of the curvature. We know that the curved mirror is formed by a sphere. So we notice that the curved mirror with the radius of curvature with the focus or the focal point. How we determine the radius of curvature? How we determine the focal point, or we call as focus. First, we cut the part, and then we notice that there will be the C. The C is the radius of the sphere. Radius of the sphere, that means that will be we use a symbol of C. Remember, that means that radius of curvature of a curved mirror is the radius of a sphere. Next, radius of curvature is the radius of the center is C. The center of curvature, that means that this will be the radius of the sphere. For the pole P, that will be the center of mirror. So this will be the center of the mirror, center of the curved mirror, and principal axis will be a line which connect the P, which connect the C to the P, the point, the pole of the P. Next, let's look at there will be lights, a series of parallel beam or series of parallel light which pass through an aperture. Aperture means a slit, which is reflected by the curved mirror. We notice that there will be a lot of the light reflected, the light ray reflected at different position. Once we reduce the aperture, that means that we brought some of the light that passed through the aperture. Since the light is blocked, that means that the reflected light which focus to a point is reduced. So that means that we continue to reduce until we get a point. So this point will be the focus where this will be the most of the light or all the lights beam that pass through the aperture, and then all of them will be focused, will be reflected and focused to a point. So we call that this point will be the focal point or focus. Focal point, or we call that is focus. That will be the rays parallel and cross to the principal axis focus at the focal point F. Ladies and gentlemen, remember, sometimes students do the mistake. Students write the focal point as the focus point. That will be wrong. If focus, that means just focus only. This is the focus. Or we said that this is focal point. For the focal length, that means that will be the distance from the focal point or from the focus to the pole P, to the pole of the mirror. Now, when a series of beams that pass through the convex mirror. So that means that all of the light reflected back. So with the angle. So that means that a series of light are reflected. That means that there will be some of the light will be go through and focus to a point. So that means that once we extend the light beam, that means that we found that it will be focused at one point. That will be the focal point. The focal point will be at the other side of the convex mirror. Meanwhile, this will be the C, and this will be the distance of, this will be the distance of C, and this will be the distance of F. F will be the focal length, and R will be the center of curvature or radius of the curved mirror, radius of the convex mirror. So focal point, ray cross and parallel to the principal axis, incident on a convex mirror, reflect and appear to diverge from the focal point F. The light of this part is diverged, reflected and diverged. So diverge, we notice that these light are diverged. That means that the other side will be focused. So for the focal length is the distance between the focal point and the pole P of the convex mirror. Next. Students, let's look at the relationship between the F and R, the focal length and the center of curvature. For a convex mirror, for a concave mirror, this will be the distance of the F. This will be the distance of the R. And the angle from C, the parallel beam, which reflected to a point of F. The angle from the light, the angle for A, the angle for B, the angle for delta, what are their relationship? So we notice that because this light beam obeys the law of reflection, FLEC, reflection. So this means that the angle of A will be equal to angle of B. Where the angle, because these two, the light beam are parallel to the principal axis. So this means that the angle of A is equal to angle of delta. Angle of A equal to B, angle of A is also equal to delta. So this means that delta is equal to A, delta equal to B as well. So as a result, we notice that AF, we can say that AF, the distance of AF is equal to the distance of CF. AF to CF, because they will have the same angle, same side of the CF, the same length of CF and same length of AF. Since CF also equal to PF, where CF also equal to PF, that means that the focal length will be half of the R. The O, we said that R is equal to 2F. R, the length of R is double of the F, or F is the half of the R. Let's go to the convex mirror. A convex mirror, where the light is reflected at the surface of the convex mirror. So same thing, we found that once the line from C will be passed through at the center of the light beam. So it will form the angle of A is equal to the angle of B. Once the angle of A equal to angle of B, that means that it will be equal to the angle of delta. So as a result, the length of AF, A to the F, is equal to the C to the F. From A, F, C, F, they will be the same length. And also CF will be equal to PF. So against proof that the F is a half of R, or R is double of F. Ladies and gentlemen, let's look at the light beam again. Where they will be all the light after reflected by the concave mirror or concave surface, all the light beam will reflected to a point of focus. Summary: concave mirror and convex mirror are two types of spherical mirror. Radius of curvature R of spherical mirror is the radius of the sphere of which the mirror is a part of the sphere. Center of curvature of a spherical mirror is the center of the sphere of which the mirror is a part of the sphere. Principal axis of a spherical mirror is the line through the center of curvature and the pole of mirror. So ray cross and parallel to the principal axis incident on a spherical mirror are reflected and focused at a diverge from a point on the principal axis known as the focal point. Next, focal length is the distance between the focal point and the pole of the spherical mirror. Parallel rays, which are not parallel to the principal axis incident on a concave mirror, are reflected and focused on a focal plane. Let's look at the concave mirror. How we draw the light ray? First, a light ray direct to the mirror. So if any point, this means that the light ray we draw against first, second, first line, green, red, and pink color. So we notice that when the light ray direct to the mirror, it will reflect to a point of focus. Where any light that pass through the focus, after reflected by the concave mirror, it will be parallel. And if we go through a point which is center of curvature, then all the line will meet together. So this will be the position of the image form. This means that first, okay, the rules, first line, ray that pass through the principal focus, pass through the F. This will be the focus point. Sorry, this will be the focal point. After passing through the focal point and reach to the mirror, it will reflect it, okay, by 90 degrees. Let's go to the next example. Let's look at this diagram. We notice that this will be the distance of F and this will be the distance of C, because the F is 1, 2 unit of the length, focal length. That means that the C will be the double of the focal length. So from here, this will be the characteristic of the image formed by the concave mirror. Where previous lesson we learned that we already learned that what are the characteristic form. So from here, if U is greater than 2F, that means that the image form will be greater, U greater than 2F. That means the image form will be real, inverted, and smaller. If U equal to 2F, very special. If U equal to 2F, that means or U equal to C. That means that the image will be real, inverted, and same size. If in between F, your object is in between F and 2F, or U in between F and C, the image form will be real, inverted, and magnified. If the object is placed at a distance less than the focal length, at this time, the image form will be virtual, upright, and magnified. So all this, the characteristic, you must remember since Form 5, or since SPM, sorry. Next, how about a convex mirror? Ray 1, we look at the ray. First, the ray parallel to the principal axis is reflected. Parallel to the principal axis is reflected. After that, okay, if the light ray direct to the C, that means that the ray direct towards the center of curve C is reflected back along the same path. Once reflected along the same path, that means that they will be they cross each other with the line here. So that means that this will be the position where the image form. Next. Summary. Two of the following three rays are sufficient to determine the position of the image formed by a spherical mirror. This means that there are three lines we must draw. First, a ray parallel to the principal axis is reflected from the focal point. Second, a ray passing through the focal point is reflected parallel to the principal axis. Next, a ray that passes through the center of curvature is reflected back along the same path. And for the convex mirror, same thing, the three beam, the three ray. A ray that is parallel to the principal axis is reflected from the focal point. Second, a ray directed towards the focal point is reflected to the principal axis. Next, a ray directed towards the center of curvature is reflected back along the same path. And the characteristic of the image formed by a concave mirror depends on the distance of the object from the mirror. Finally, the image formed by a concave mirror depends on the position of the object, where the image formed by a convex mirror is always virtual, upright, and smaller. Let's go through the diagram. What is meant by linear magnification? Linear magnification, this means that enlargement, that is the ratio of the enlargement of the image. The image become bigger or image become smaller, magnification. Ladies and gentlemen, let's look at the image form. Now we notice that the image is shorter than the object. Meanwhile, the image is smaller than the object. So the distance of the object from the mirror, we use a symbol of U, where this is the object distance. Distance between the image from the mirror, this will be the distance of V. So we go through the derivation. So we notice that the height of the object, height of the image, the ratio of the height of the image divided by the height of the object is equal to the distance of V, divided by distance of U. Where the triangle OPQ, and the triangle NPI. Okay, so that means we just use the ratio. So the triangle APF, the triangle of APF and INF, A, P, and F. APF, the triangle. And the triangle of I and F. These two triangles. Let's look at the two triangle, this part and this part. So we notice that there will be height of the object, height of the image divided by height of the object, and we derive, okay, at the end we get the formula 1 over u plus 1 over v equal to 1 over f, where we call this will be the formula for the mirror, and also use the from that, and also the formula used for the lens. 1 over u plus 1 over v equal to 1 over f. This will be the formula formula to show the relationship between the focal length, between the object distance, and also the image distance. Now, let's look at the light ray again. For the convex mirror. Convex mirror showed from the virtual image. That means that the image formed at the other side. So same thing. Once we find the triangle OPQ, O, P, and Q, compared to the triangle IPN. The ratio height of the image divided by the height of the object equal to the distance of V. Distance of V, image distance, divided by the object distance. Ladies and gentlemen, we notice that there is a negative sign. This negative sign shows that the image formed by the convex mirror is a virtual image. So the negative here shows that this image form is a virtual image, because all the image formed by a convex mirror are virtual. So at the end, we still get that, we still derive, after we derive all the formula, we still found that 1 over u plus 1 over v is equal to 1 over f. As a conclusion, the formula used for the convex mirror or concave mirror are same. That will be 1 over u plus 1 over v equal to 1 over f. Let's look at the sign. U, V, and F. U can be positive, U can be negative. V and F also can be positive and negative. If the object distance is positive, means the object is real. Same with the image. If the U is negative or V is negative, means this U is virtual object distance. And this V negative means that the image will be virtual. For F, positive for concave mirror, negative for convex mirror. Real image means that the image that can be formed on a screen. Virtual image means that the image that cannot form on the screen. Ladies and gentlemen, we must make it clear What is meant by the image can form on the screen? For real image can form on the screen. We can see the image on the screen. For the virtual image, the image cannot form on the screen. That means that none of the image can seen on the screen. For example, before we go through an example, let's think about it. If there is a real or virtual image, any real or virtual image, can we see by our eyes? Can we see the image in or on the optical instrument? For example, plane mirror. What the characteristic of the image formed by a plane mirror is same size, same distance, just lateral inversion. That means left-right inversion. Okay, left and right inverted. So the image form will be upright. Okay, this one we know. But for a plane mirror, the image formed by a plane mirror is virtual. Virtual means that the image cannot form on the screen. Image cannot form on the screen. That means we can't see the image on the screen. But when we look through the mirror, when we look at the mirror, we notice that the image still form in the mirror. That means that for a virtual image, it just cannot form or reflected and form on the screen. For real image can form on the screen. For the real image and virtual image, we can view or we can see the image form in or on the instrument. We can see the real image in the concave mirror. We also can see the virtual image in the convex mirror, in the concave mirror, and also in the plane mirror. So that means we must make it clear. For real image, no problem. Everywhere we can see the either in the instrument, optical instrument, or on the screen we can see. Virtual image, we just can see the image in the optical instrument, but we cannot see the image that reflected and formed on the screen. There will be no image formed on the screen. We just can view a black spot only. No clear image form. Next. Let's look at the object. If we move the first, we move nearer and nearer, we notice that when they are the distance u equal to v, that means that the height will be equal, the size will be equal, and the linear magnification will be 1. And we continue. Ladies and gentlemen, we look at here. At this position, the image linear magnification for the image will be 2. This will be 1.33, 1, 0.8, 0.67, 0.5. That means that this for 35 cm and above, 30, 35 cm of the object distance, it will form the linear magnification greater than 1. After that, less than 1. So if greater than 1 is 2 now, how about when it's at 1? 1 means that same size, same height, the image, same size with the object. Once the object moves further, we notice that the image is smaller. Image is smaller, that means that linear magnification will be less than 1. Now, we look at here. If the linear magnification is 1, that means that object same size with the image. If the linear magnification is greater than 1, that means that it will be the image is greater than the object magnification. If the linear magnification is less than 1, 0 point something, that means that it will be the image is diminished image. If m linear magnification equal to 1, that means same size. So as a result, if we plot the relationship, we plot a graph for V against V against U, we will get that this will be, it will be a curve. Where if we plot another line, where U equal to V, where U equal to V, the gradient V over U, the gradient will be the linear magnification. Okay, so from here, V equal to U is equal to 40. We also can set that from the relationship, 40 will be the V equal to U. Why V equal to U? Because V equal to U at this moment, sorry. Okay, when V equal to U, means well, the linear magnification will be equal to 1. That means object distance equal to image distance. U equal to V. U equal to V, that means object U, where is the object? Object is at C. When object U equal to C, V also equal to C. That means that C is equal to 2F. So that means F will be equal to, divided by 2 will be equal to 20 cm. If there is a graph of 1 over V against 1 over U, normally the line will be a straight line with negative gradient. So from here, we use that y equal to mx plus y equal to mx plus c. Y is equal to 1 over V. 1 over V plus 1 over U will be equal to 0.05. So this means that by using the formula 1 over U plus 1 over V equal to 1 over F, we replace in 1 over F. So from here, we notice that 1 over U plus 1 over V is equal to 0.05. Because we get the any point, this will be 0. U 1 over U is equal to 0.05. 1 over V, 0. Or this point, 1 over U is equal to 0, but 1 over V is equal to 0.05, same thing. So at the end, we get that one of them becomes 0.05. That means that 1 over F is equal to 0.05. So from here, we resolve 1 over 0.05, we get it. The F is equal to 20 cm. As a conclusion, object distance U, image distance is V, focal length is F, their relationship is 1 over U plus 1 over V equal to 1 over F. The real is position a positive sign convention. Object distance u is positive, it is real. And u is negative for a virtual object. V is positive, image distance V is positive if the image is real. And V is negative if the image is virtual. Next, F for the focal length, F of a concave mirror is positive. For the convex mirror is negative. The linear magnification M will be equal to height of the image divided by height of the object. Or it will be equal to V divided by U. These are the all we discussed just now. Okay, so now let's go to the question for today's lesson. Question 1. Question 2. Question 3 and question 4. Question 5. Question number 6. Question number 7 and question number 8. Here will be the answer for the question number 1. Question number 2. Answer for question number 3. Answer for question number 4. Answer for question number 5. Answer for question number 6. And also answer for question number 7. And also the answer for question number 8. That's all for today's lesson. Thank you very much and hope you enjoy my lesson. We continue again for next lesson. Thank you very much and see you on next lesson.